Okay, so today we're going to get into the reaction quotient. What is the reaction quotient? Well, it's a way that we use to predict which way the reaction will proceed if it is not at equilibrium. So if we know some concentrations in a system, but we don't know if it's at equilibrium or not, this is a way to figure out which way, first of all, is it at equilibrium, and then second of all, if it's not at equilibrium, which way will it proceed? So we solve for Q, so reaction quotient is abbreviated Q, and we solve for Q just like we do K with the equilibrium expression, or our reaction quotient expression. We just make it equal to Q instead of K. The easiest way to do it is once you know K and you know Q, once you calculate Q, you're going to put Q and K on a number line. Q will try to get to K. So let's say, here's my number line. If Q is less than K, then the reaction will proceed to the right, because Q will try to get to K. So if Q is less than K, the reaction will proceed to the right. If Q is greater than K, the reaction will proceed to the left. Because, again, Q is trying to get to K. And if you think about it, if Q is less than K, that probably means that our top number, our numerator, is smaller than it needs to be. And so we need more product because the products are in the numerator. That's why it's going to have to shift to the right towards the product. If Q is greater than K, that probably means we need more in the denominator, we need more reactants, so it's going to shift to the left. Now, if Q is equal to K, then what does that mean? Hopefully you guessed that the system is at equilibrium, because that means we already have K. We already have our equilibrium constant. So if Q is equal to K, then our system is at equilibrium, and there won't be any shift right or left. So let's do this example here. In an experiment, 0.1 moles of NaCl, 0.001 moles of NO, and 0.0001 moles of Cl2 are mixed in a 2-liter flask. Here's my equation. What is the value for Q? And then what direction will the reaction proceed if K is 1.55 times 10 to the minus fifth? Okay, so the first thing we need to do is write our expression. So Q is equal to NO squared Cl2. It should look exactly like your equilibrium expression, except for instead of being equal to K, it's being equal to Q. Then we're going to plug these numbers in. Now, we're given moles and volume, so we need to convert each of those to molarity. So for the NO, we have 0.0001 divided by 2. 0001. Delete. So we get 0.0005. So that's going to go here. So 0.0005 05 squared times the Cl2, which the Cl2, actually I messed that up. This should be Cl2. So this is our Cl2 number. The NO is just 2 zeros, so 0.001 divided by 2. So that's going to be 3 zeros. 1, 2, 3, 0.005 squared times the Cl2, which is that, over NaCl, which is 0.1 divided by 2, which would be 0.05 squared. Okay. So this all is equal to Q. So I'm going to do 0.0005 squared times 0.00005, enter, divided by 0.05 squared. All right, and I'm going to put that in scientific notation. So it's 5 times 10 to the minus 9. So Q equals 5 times 10 to the minus 9. Okay. So there's my Q. That's my value for Q. That answers the first question. Now I have to see which direction the reaction will proceed. So I'm going to put it on a number line. So K is 1.55 times 10 to the minus 5th. Q is a lot smaller than that. 5 times 10 to the minus 9th. So Q will try to get to K. So will work its way to get to K. So the reaction will proceed to the right. Reaction proceeds right, or towards the products if you want to write it that way. Okay. So that is how you do solving for Q. So you solve for Q using the numbers in the problem, then you compare it to the K given, and then figure out which way the reaction will proceed, to the right or to the left. All right, hope this helps. Let me know if you have any questions.